the Chapter 3 Python programming presentation. If you haven't watched any of my videos yet, I made an agenda of presentation, basically saying that I'm going to talk about the bolded terms and I'll give you guys time to look at some of the other definitions. The visuals that I provide are supposed to emphasize the important content that we've learned. Understanding strings and basic operations. The length, or len, function returns the number of characters in a string. Brackets, in the terms of indexing, are for accessing specific characters in a string, and a formatted string literal, also known as an f-string, embeds variables inside curly braces within a string. Example of use of the length function is given in participation activity 3.1.5, where there is a variable named John_F_Kennedy equals a string J, F, K, in which in the final line is given to a print function where it uses the length function, in which in the output it provides the number of characters in the string for the variable John F. Kennedy. With lists, also known as something like a versatile container. Lists are an ordered, mutable collection of elements. Elements are individual items in a list. An index is a position of an element in a list of which starts at 0. An append function adds an element to the end of a list. The pop function removes and returns the last element or a specified index. The remove function deletes the first occurrence of a value from a list, and sequence type functions are given. They're built-in functions for lists. Information is covered in the Xilabs activity 3.12.1, List Basics. I won't go through the entire instructions, but in essence, it says that given the input shown, it should provide the output shown. Work I provided for that Xilabs activity, given with that blue arrow to show the continuation of the code that wouldn't fit on the screen otherwise, I labeled all the different outputs from A to E in red brackets, and I put them on the actual programming that I provided to show at which point throughout the program each print statement provides that particular output. Feel free to pause at this point and look at things as you feel are necessary. Tuples and sets. Sets are an unordered collection of unique elements. The set function creates an empty set. Set literals given with those curly braces define a set with unique values. And modifying sets as well as set operations are going to be given on a photo on the next slide. Sets and set operations. For the modifying sets, it's given those functions in front of you. And for set operations, we'll go a little bit more in depth with these. But in case you wanted to see a collective list of them, this is what we've got. Diagram visual of those set operations mentioned previously. For a union of which combines all unique elements from sets A and B, it creates an intersection from values of A and B that are unlike each other, but combines them together. For set intersection of sets A and B, it only combines the common element between the two. For the set differences of A and B, it will take the elements in set 1 but not in set B, of which will disclude those from set B that were already in set A or set 1. And for set symmetric difference of set A and set B, it gets rid of the things that are in common and only provides the things that are unlike each other. Key value mappings. Dictionary or dict, a mapping of keys to values. And for an example, in curly braces, name, which is a string, is going to be assigned the variable or the values Alice, string, age, and 25. A key is a unique identifier for a value in a dictionary. A value is the associated data stored under a key. Accessing values, given the function in that line, it retrieves that value. Modifying dictionaries is also going to be given on a photo on the next slide. In dictionaries, these are the two lines that I think are the most relevant from all the things that we've learned. So I'll just leave these here in case you'd like to go back and look at them later. Types and type conversion, we have implicit conversion, which is an automatic type conversion. For example, if we combine an integer value and a float value, and we equated that expression, it would result in a float value. The binary numbers are a base 2 representation. An example given is something like 0b1010 is the equivalent of the value 10. And decimal numbers in base 10 are the values that we use in our standard number system here today. Video. I hope this helped. Good luck!